Hello, all you intelligent people out there. This is our first page of graphing hyperbolas. A hyperbola is our fourth conic we're going to look at, and it is actually made up of two curves. So on this one, this red curve that goes to the left and this red curve that goes to the right, those two pieces together are the hyperbola. This one we have the red curve going up and the red curve going down. So those two pieces are the hyperbola. All of this other stuff is not actually part of the hyperbola, it's what helps us graph the hyperbola. If you look at our equations, they look almost identical to the ellipse except that they have a minus sign instead of a plus sign. Notice when it's x minus y, we open left and right. But when it's y minus x, we open up and down. The h and k are still the center. The vertices are still based off of the a, but this time the a is not necessarily the bigger number, it's just the one that's first. It's always a squared minus b squared. A squared minus b squared. So for the left-right parabola, from the center you'd go to the right and to the left. Where up-down, from the center you'd go up and you would go down. The covertices, and I put those in quotes because they're not actually called covertices because they're not part of the graph. They just help us create this box. So when we open left, right, the covertices would go up and down. When we open up and down, the covertices would go left and right. Okay. The foci, our focus points, have to be out here inside the hyperbola because our hyperbola always curves around those focus points. So this time it's c squared equals a squared plus b squared instead of minus. And if the vertices go left and right, then our focus points go left and right. If the vertices go up and down, then our focus points go up and down. These asymptotes are the diagonals of the rectangle. That's why we want to draw this rectangle, because the diagonals of the rectangle are the asymptotes. So the equation for those, well, we just need, I did point slope form of a line. Y minus y1 equals m times x minus x1. Well, the center is always a point, so y minus k and x minus h. Here we go up and down b and left and right a, so the slope is going to be b over a. Where here we go up and down a, but we go left and right b, so our slope is a over b. And notice one of the lines goes downhill and one of the lines goes uphill, so that's why I put a plus minus out front. All right, so first example here, x squared over 16 minus y squared over 81 equals 1. So the first number is always a squared, so that means a equals 4. The second number is always b squared, so that means b equals 9. There's nothing in the parentheses, so our center is 0, 0. So I put the center at 0, 0. I go right 4 and left 4, and then I go up 9 and down 9. And those 4 points are the midpoint for the rectangle, so we draw our rectangle using those 4 points. And I knew that it was going to go left and right because the x squared came first. So then I drew the diagonals of the rectangle. There's our vertex, so you make sure you touch the vertex and draw the graph approaching the asymptotes. The focus points, well, c squared equals a squared plus b squared, so c is the square root of 97. So you go approximately out the square root of 97 and just plug that into your calculator, of course. So right 4, left 4 are vertices, up 9, down 9 were the covertices, and then right square root 97, left square root 97 were the focus points. Okay. Equation for our asymptotes, well, the h and k are both 0, so y minus 0 and x minus 0 don't really matter. We went up 9 and over 4, so our slope is 9/4, so y equals plus or minus 9/4 x. All right, so b, y squared over 9 minus x squared over 25 equals 1. This time it's y squared minus x squared, so this hyperbola is going to open up and down. The first number is always the a, so in this case a equals 3. The second number is the b, so b equals 5. Again, there's no h and k, so our center is 0, 0. The vertices this time go up and down, so from the center up 3, down 3. And the co-vertices are underneath the x. They go left and right, so right 5, left 5. Those 4 points help us make the box. Remember, those are the midpoints for our box. And then we have our 2 diagonals, which are the asymptotes. And I just noticed I forgot to write this down, so this would be 0, comma, plus or minus the square root of 34. Okay. And the equations of our asymptotes, well, again, the h and k are both zeros, so y minus 0 and x minus 0. This time we went up 3 to the right 5, so our slope is 3/5, but there's an uphill one and a downhill one, so that's plus or minus. Okay. And because it was y squared, we go from the vertex and we approach the asymptotes, but we don't touch the asymptotes. Remember, we just approach but do not touch. All right, and I'm going to be moving on to page 2, where we will no longer be centered at the origin.